Hello students, so this class is based on factorization of quadratic polynomial using a specific method. In the previous class we have also discussed about factorization of quadratic polynomial using a method that is known as factor theorem. Okay, where we have to factorize a quadratic polynomial into the product of two linear polynomial. Okay, and in this class also we will factorize that same quadratic polynomial but using a different method, and that method is known as middle term splitting method. Okay, so this class we will study about what is middle term splitting method and how can we factorize a quadratic polynomial using this method. Okay, so before starting this method we have to get some idea about middle term splitting, okay, and quadratic polynomial. Keep in mind, any quadratic polynomial means its degree is 2. Okay, so any quadratic polynomial can be written in the form ax square bx plus c. This is a quadratic polynomial. As you can see, the highest power is 2, so it is a quadratic polynomial. This is the general equation or general equation of quadratic polynomial. Clear? So a quadratic polynomial can be written in this form. Okay, you can compare this quadratic polynomial with a quadratic polynomial as I am writing here, 2x square, okay, plus 5x plus 3. It is also a quadratic polynomial and it is also a quadratic polynomial. In this case, the coefficient of x square is a, and here the coefficient of x square is 2. So both are comparatively same because both are quadratic polynomial. So we have to compare the coefficient of x square with this polynomial. Okay, so here the coefficient of x square is a, but here the coefficient of x square is 2. So you can write a is equal to 2. Okay, similarly here the coefficient of x is b, and here the coefficient of x is 5. Here the constant term is c, and here the constant term is 3. So you have to only remind that any quadratic polynomial can be written in the general equation form ax square plus bx plus c. Okay, now you can see this quadratic polynomial has 3 terms. Okay, these are the two terminal terms. Terminal terms means they lie at the two terminal. Two terminal means two ends. These two terms lie at two ends. So that is why they are known as terminal terms. Besides these two terms, there is another term, and this term is known as middle term because it lies at the middle. So this is known as middle term. Clear? So in the middle term splitting method, we have to split the middle term. Here the middle term is dx. Okay, basically we will split the middle term here. The meaning of splitting is to break. Okay, the meaning of split means to break. So here we will do what? Here we will break this middle term into two parts. Clear? Here you can see the middle term is 5x, or you can say only the coefficient, that is 5. So we have to split this middle term into how many parts? Into two parts. Okay, it is divided into two parts. So that the two parts form, suppose this is a part and this is a part. Okay, so that the two parts formed, after adding they will give 5. After adding these two parts will give 5. Okay, this is the first thing that you have to remind. And the second thing is, whenever these two parts will be multiplied, suppose this is the first part and this is the second part. Whenever these two parts will be multiplied, then what will they give? they will give the multiplication of a coefficient of x square and coefficient of the constant. Again I am saying, whenever this two part will be multiplied, okay, they will give the multiplication of the coefficient of x square. Here the coefficient of x square is 2, multiplication and the coefficient of constant, that is 3. That means they will give 6. Clear? Here you can see, here suppose b is the middle term. So b must be divided into how many parts? It must be divided into 2 parts. Okay, so that whenever this 2 part will be added, this part plus this part, it will give what? It will give b. Here this 2 part will add to give 5. Clear? And when this 2 part will be multiplied, they will give what? They will give the multiplication of coefficient of x square and coefficient of constant AC. Okay, so this has to be keep in mind. Here takes 2 points, assume 2 points such that whenever they will be added, they give 5. Take any 2 points. Whenever they will add, they give 5. Suppose we can take at this point, we can take 1. Okay, 5 can be divided as 1 and 4. Yes or no? Yes. Why? Because if I will put 1 here and 4 here, it will be 5. So it is satisfied. So I can say yes, 5 can be divided into 2 parts. First part is 1 and second part is 4. But if I put 1 here and 4 here, and after multiplication, did they give 6? No. 1 into 4 is 4. So finally we conclude that no, 5 cannot be divided into 1 and 4. Clear? So we cannot write the first part as 1 and the second part as 4. Let us assume another 2 pairs. Suppose I am writing here 2 and another part is 5 is divided into 2 and 3. Now if we add them, what they give? 2 plus 3 is 5. Yes, it is satisfied. Now coming to the second condition, here 2 is placed, here 3 is placed. Now you see 2 into 3 is 6, hence it is right. That means yes, 5 can be divided into 2 parts, that is 2 and 3, such that whenever 2 and 3 are added, they will give 5. Whenever 2 and 3 are multiplied, they will give 3 into 2 is 6. Okay. Suppose we can take another example. If there is a question x square, okay, plus 7x plus 12. Okay, so it is a type of quadratic polynomial. And here you can see, here a is how much? Coefficient of x square is 1, because it should be compared with ax square plus bx plus c. So here coefficient of x square is 1 and here coefficient of x square is a. So a is 1. This is clear. And b is 7. Clear. And c is 12. Now here the middle term is 7. So I am writing here, this is the middle term. That means, it means we have to split or break, okay, this 7 into 2 parts. So that what will happen? So that, see, first I am writing the coefficient of x square is a here and the coefficient of constant term is c. So I am now multiplying the coefficient of x square with the constant term. Here a is 1 into c is 12. So it will be 12. So now we have to divide or break this 7 into 2 parts, so that whenever they will be added, okay, suppose I am writing this is a part and this is a part. Whenever they will be added, this plus this, it will give what? It will give 7. Here. And whenever these two will be multiplied, then they will give what? Then they will give AC, multiplication of coefficient of x square and coefficient of constant. Clear? 1, this is 1 coefficient of x square, this is 12, so 1 into 12 is 12. So whenever these two parts or two numbers will be multiplied, they should give 12. So assume, think a pair, so that they will give 7 as addition and 12 as multiplication. Suppose I can take 1, 6. So if I will write 1 and 6 here, then 1 plus 6 is 7, it is correct. But if I will multiply them, does it give 12? No, 1 to 6 is 6. So it is impossible. Okay. Now we can take 2 here, 5 here, because 2 plus 5 is 7. And 2 into 5 is it 12? No, it is 10. So it is also impossible. Then I can take it 3, then it must be 4. So 3 plus 4 is 7, and 3 into 4 is how much? 12. So this is the correct assumption. So we can divide or break the middle term 7 into two parts. First part is 3 and second part is 4, so that they will give 7 as addition and 12 as multiplication. So basically we have to break this middle term into two parts. Clear? So basically there are 4 types of question must be asked in your examination regarding the splitting of middle term. Okay? So let us discuss what are that 4 types of question. In the type 1, the question may be like this: x square plus 5x plus 6. Okay? Here you can see there are two positive signs. Positive, positive. This is the type 1 question. May be asked. And in the second type question, it is like this: minus 5x plus 6. That means first sign is negative and the second sign is positive. And in the type 3, it may be the question like this: the first one is positive, okay, and the second one is negative. So plus, minus. Now coming to the type 4, you can assume what must be the type 4. In the type 4, we have two negative signs. Okay, so these are the most important types of quadratic polynomial whose factorization must be calculated through splitting of middle term. So in this session we will basically study about or discuss about these two types of splitting of middle term method. Okay, so let's start with the type 1. So let us discuss how the splitting of middle term is operated by taking an example. This is an example of type 1 type. Okay, so here we have to factorize the quadratic polynomial x square plus 5x plus 6 by middle term splitting method. Okay, so here the middle term is 5x. So first we have to compare this, okay, with the general equation of quadratic polynomial. This is the general equation of quadratic polynomial. Okay, so from here you get what is the value of a. A is the coefficient of x square. Here coefficient of x square is 1. Now it is clear. Again, the value of b is, you can see here, 5, and the value of c is 6. Out of these 3, this is the middle term. Ultimately we will split or break this middle term into two numbers or two parts. Okay, and here the multiplication of the coefficient of x square, that is a, and constant, that is c, is how much? You can see here a is 1, c is 6, that is 6. So it means what? It means we have to divide this 5, or we have to break this 5 into two parts. Okay, so that their addition will give how much? 5. Okay, and their multiplication will give how much? See, this is 6. Now we will break this middle term 5. Okay, we can assume any number. Suppose I can assume 1 or 4, or I can assume 2 or 3. Okay, but it will be very easy if you will calculate the factorization of 6, or if we will factorize 6, then it is very easy to break this 5 into 2 number. So let us factorize this 6. So the factorization of 6 is 2, 3, 3, 1, and so we can get 6 is equal to, look at carefully, 6 is equal to 2 into 3 into 1. So these 3 number will be multiplied to give 6. Now we have to break 5 into 2 parts or 2 numbers. So we have to choose 2 number, okay, or a pair. Suppose I am taking 1 as a number. Now the remaining part is 2 into 3. So there is 6. Again I am saying, if I am taking 1 as the first number, then the remaining part 2 into 3 will be the second number. And if we will add them, then it will give 7, and multiply them, it will give 6. But we need 5, but it gives 7, so it is impossible. So we cannot take 1 as a number. Now it is clear. Suppose I am taking this as a pair. This 3 into 1 is 3, and the remaining part is 2. Okay, so among all these 3 numbers, you have to choose any 2 number or a pair. So 3 into 1 is 3, we can take, and 2 is another number. So we have 2 numbers, 3 and 2. Let us add them. It will give 5. Let us multiply them. It will give 6. So it is clear now. So the 2 number will be 3 and 2. Okay, so we can write 2 and 3. 2 and 3 are the 2 numbers, so that when they are added, they give how much? They give 2 plus 3 are 5. And when they multiplied, they give, let us multiply them, they give 6. So the 2 numbers are 2 and other is 3. Hence 5 can be splitted into 2 parts. First part is 2 and second part is 3. Now write this. Hence x square plus 5x plus 6 is equal to. So which part is being splitted? This part, this 5 is being splitted. So I am writing 5x edge. See, we have 2 number here. Yes or no? So I can write 5 edge or 5x edge 3x plus 2x. Okay. Then for 5x I have written 3x plus 2x because 3x plus 2x is equal to 5x. Now the remaining part is 6. I can write 2x plus 3x, but always keep in mind you have to write the bigger number at first, then the smaller number. Okay. Now 5 is divided into 2 parts, that is 3x and 2x. So put the bracket over the first 2 number and last 2 number. From the first 2 number, take some variable or some constant as common if possible. So here you can see, here x contains, here also x contains. So x can be taken as common from the has 2 terms. Now what will be remaining? If one x is being taken as common, then the remaining part is x, because x into x is x square, plus when x is taken as common, the remaining part is 3. Now this is clear. Plus again from this two part, which number or which variable may be taken as common? We can take or we can write 6 h 2 into 3. We can write it. Yes or no? Yes. 6 can be written as 2 into 3. Now tell me, among these two or between these two terms, which constant may be taken as common? You can say 2 can be taken as common. So the remaining part is x plus, here 2 is taken as common, so 3. Again, this is the first term, this is the second term. Now we convert this into this. Now can you say from the first term and from the second term which term may be taken as common, or which term is common both in first term and both in second term? As we know, x plus 3 is present in the first term. Here also x plus 3 is present in the second term. So x plus 3 is the common term. So we can take x plus 3 as common from this two term. If x plus 3 is taken out as common from the first term, then the remaining part is x only. Okay, then plus sign. When x plus 3 is taken as common, then the remaining part is 2. Finished. This is our answer. Because you can see, if this is the quadratic polynomial, it is expressed as the multiplication of two linear polynomials. These two are linear polynomial. Okay, so we can write, finally we can write that x square plus 5x plus 6 is equal to product of x plus 3 and x plus 2. Okay, hence a quadratic polynomial can be factorized into two linear polynomials. Okay, so this is the procedure. You can follow this procedure in order to factorize a quadratic polynomial. Okay.